Hi friends, today I'll walk you through a use case for retrieval augmented generation that we learned in our last session. If you've not watched previous videos on AutoGen as well as retrieval augmented generation yet, please watch it here before watching today's video. In this application, we will take a look at RAG agents of AutoGen and its usage. We'll explore customizations of RAG agents using embedding function, text split function and vector DB. Then we'll discuss more advanced ways to integrate RAG with AutoGen and conclude. RAG has emerged as an option to overcome some challenges of LLMs by connecting to external data. To build a RAG agents of AutoGen, we will need a retrieval augmented user proxy agent that's an extension of built-in agents and an assistant agent acting as a conversable agent configured with LLM. We will start by initializing these two agents. RAG user proxy specifies a path to the document collection, while the RAG assistant can download the documents, break them into chunks of defined size, compute embeddings, and store them in a vector database. Once a chat is initiated, the agents engage in code generation or question answering. Here's a rough procedure that they follow. RAG user proxy retrieves document chunks based on the embedding similarity and sends them along with the question to the RAG assistant. RAG assistant employs an LLM to generate code or text as answers based on the question and context provided. If the LLM is unable to produce a satisfactory response, it is instructed to reply with update context to the RAG user proxy. If a response includes code blocks, the RAG user proxy executes the code and sends the output as feedback. If there are no code blocks or instructions to update the context, it terminates the conversation. Otherwise, it updates the context and forwards the question along with the new context to the RAG assistant. If the RAG assistant receives update context, it requests the next most similar chunks of documents as new context from the RAG user proxy. Otherwise, it generates new code or text based on the feedback and chat history. If the LLM fails to generate an answer, it replies with update context again. This process is repeated several times. The conversation terminates if no more documents are available for the context. Let's look at how to build this now. Start with installing dependencies. To extend support of document types, you'll need to install a library called unstructured. Then import agents like AutoGen, assistant agent and user proxy agent. Basic configurations are as you see here. For assistant agent, name, system message and config info are some of the parameters. For RAG user proxy agent, name and retrieve config are the parameters. Retrieve config is where you can specify a document to use for information. For more information, please refer to this doc, link provided in the description below. Once you're done with setup, initiate chat and ask a question to RAG user proxy agent. Your question in this example is, what is AutoGen? Answer you receive is this. AutoGen is a framework that enables the development of large language model (LLM) applications using multiple agents that can converse with each other to solve tasks. The agents are customizable, conversable, and allow human participation. They can operate in various modes that employ combinations of LLMs, human inputs, and tools. Now, create a user proxy agent and ask the same question. As you see, that the output of user proxy agent is not related to AutoGen since the latest info of AutoGen is not in ChatGPT's training data yet. But the output of RAG user proxy agent is correct as it can perform retrieval augmented generation based on the given documentation file. RAG user proxy agent is customizable based on several parameters and different use cases. Here we will customize with embedding function, text split function and vector database. Text embeddings are important because they allow for capturing semantic relationships and efficient representation of text data. You can perform text embedding using OpenAI, Cohere or Hugging Face functions. In this example, to an OpenAI embedding function, you can provide an API key and a model. Before we can store the documents into a vector database, we need to split the texts into chunks. You can use all the text splitters in LangChain. You can provide text separators and method to split text as a parameter to RAG proxy agent. To store documents, you can Chromab, Mongob, or any other vector DB. To configure, you just need to set vector_db parameter to your vector DB. To look at more advanced usage of RAG agents, let's integrate it with other agents in a group chat. For that, you'll need to call it from a function. Here, as you see, user proxy agent is a master who asks questions and gives tasks. RAG user proxy agent is an assistant to its master that uses its retrieval power for code generation and responding. Then there's a hierarchy of assistant agents that each has their own roles, such as product manager, engineer, and code reviewer, as in this example. Full example link is in the description below. Here's how you can build a chat application with Gradio and AutoGen. First you initialize agents, then you initialize chat with parameters like configurations, a problem, number of results, etc. Then you wrap AutoGen into a function like this. This will chat with agent through a terminal. You set up a queue and process function with arguments. Then you start the process with defined rules for termination and exception. For user interface, you can use Gradio. It sets user controls for a chatbot and text boxes, one for a question and other for a password, and a drop-down for various model choices. That's the fully working app that you see here. Up next are more AI agent frameworks from our previous list. We'll also take a look at more such examples on AI agent frameworks. So, stay tuned and keep watching AI-powered software engineering. Please like, share, and subscribe to this channel for more such videos on AI agents and other topics. Thanks for watching!